Hello everybody. Now, as I told you, in this lecture we are going to continue with the analysis of reducing sugar from honey by Coolidge ferricyanide method. So, as we know that honey contains disaccharides such as sucrose and maltose in a small quantities. The hydrolysis of sugar, that is sucrose, a disaccharide into its component monosaccharide, that is glucose, fructose. Okay, it's called inversion. It's called inversion. So during inversion, the following reaction takes place. Sucrose in presence of water gives you glucose and fructose. When here in the reaction, you can see sucrose give you glucose and fructose. What happens when 10 polarized light is passed to the solution of pure sucrose? It rotates to the right hand side. Okay, as hydrolysis reaction takes place, the solution will contain sucrose and glucose. Okay, sucrose and glucose. Along with that, there is a fructose. Okay, now this all three components are there in the reacting flask. So hence the amount of rotation is get reduced. When the hydrolysis reaction is complete, solution will contain only monosaccharide, that is glucose and fructose. Hence the direction of rotation is completely changed, that is inverted from the right to the left. Okay, initially it was rotating like this. Okay, now it is rotating like this. Okay, so provided that condition should be maintained and in a proper way. Okay, so the process is therefore called as an inversion. Thus, during hydrolysis reaction, non-reducing sugars are get converted to the reducing sugar, which can be determined by Lane-Anon method, that is called as a Coolidge ferricyanide method. Coolidge ferricyanide method. So, see what is a Coolidge ferricyanide method. Okay, so use of ferricyanide for the quantitative estimation of sugar was introduced by Hagedorn, Hagedorn, okay, and Johnson in 1923, okay, and the same methods were extended by Hens in 1929 and Hulme and Narayan in 1931. Reducing sugar like lactose, glucose, which contains a free aldehyde or ketonic functional group, reduces the ferricyanide solution to ferrocyanide solution. Aldehyde and ketonic group reduces the ferricyanide group to or solution to ferrocyanide in alkaline medium, provided that the condition or the reaction medium should be alkaline. The oxidation is accelerated by heating the solution, which help in expelling out the dissolved oxygen in the water. Ferricyanide is slightly colored solution, hence detection of endpoint becomes difficult. So Sidney William Cole modified the original method by addition of methylene blue to detect the endpoints of the titration. Cole ferricyanide method. Okay, in the Cole ferricyanide method. So methylene blue is added to the solution when almost all ferricyanide is get converted to the ferrocyanide, and the methylene blue is being a redox indicator has a two different color in the two different form, that is in oxidized form and redox form. It shows methylene blue shows two different color. Okay, and when that is added, when ferricyanide is get completely converted to the ferrocyanide. Thus when the excess of glucose solution is added after complete reduction of ferricyanide to ferrocyanide, it reduces the methylene blue to the colorless leucobase. The color of methylene blue reoccurs after some time due to aerial oxidation. So what happens? See now, preparation of solution. These are the solution required for the polyferricyanide method. 1% K3 FeCN6, then 2.5 normal NaOH, 5 normal HCl, 1% methylene blue, 1% glucose solution, honey sample solution. Okay, so 10 gram of honey is required over there. So first is the standardization of K3 FeCN6. Pipette add 25 ml of K3 FeCN6 in the evaporating dish. To it add a 5 ml of 2.5 normal NaOH solution. boil it very well, titrate the hot solution against 1% glucose solution till it becomes pale yellow in color. After a few drops of methylene blue indicator, and continue the titration till the solution becomes colorless. Note down this reading as a ml. Note down this reading as a ml. ओके, कशाच्या अगेन्स्ट टायट्रेट केलं आपण? जे वरचं जे सोल्युशन होतं काय घेतलंय बघा, पुन्हा मी रिपीट करतोय. 25 ml K3FeCN6, त्याच्यात 5 ml काय टाकलं? NaOH सोल्युशन टाकलं, ते बॉईल केलंय. आणि टायट्रेट दिस हॉट सोल्युशन अगेन्स्ट 1% ग्लुकोज सोल्युशन till the solution turns pale yellow in color. Then add few drop of methylene blue indicator and continue titration till it becomes colorless. पहिला कसा झालाय तो? येलो इन कलर, पेल येलो इन कलर. ओके, ग्लुकोज बरोबर. आणि नंतर पुन्हा मिथिलिन ब्लू टाकल्यानंतर पुन्हा तो कलरलेस होईपर्यंत टायट्रेट करायचा आहे. तर त्याचा A सेंटीमीटर क्यूब म्हणून नोट करायचा आहे. नाउ एस्टिमेशन ऑफ रिड्युसिंग शुगर. दिस वाज स्टँडर्डायझेशन ऑफ दिस वन. Okay, now using this we are going to do the estimation. Okay, estimation of reducing sugar. Now pipette out 25 ml of K3FeCN6 in a evaporating dish, add 5 ml of 2.5 normal NaOH solution and boil it. Then titrate this hot solution against the prepared honey sample solution till the solution becomes pale yellow in color. Add few drop of methylene blue to this as an indicator. Then continue the titration till the color becomes colorless, and note down this as a B centimeter cube, as like a previous one. Okay, so now here instead of there, here you are taking honey. Here you are taking honey, and what was there? What you was taking there? See, what you was taking there? 1% glucose solution. This was titrated against glucose solution. Here it is titrated against honey. Estimation of reducing sugar after inversion. This was a before inversion. Now after inversion, we put out 25 ml of stock solution in a round bottom flask. Add 10 ml of 0.5 normal HCl. Now you are adding here HCl and reflux the solution on water bath for an hour. Cool the content and neutralize the acid with the help of sodium bicarbonate. Dilute the content in 100 ml volumetric flask. Okay, then with the help of distilled water, titrate this solution against the standardized K3FeCN6 under the boiling condition using methylene blue as an indicator. So continue the titration till the solution becomes colorless, and note down this reading as a C. This reading as a okay. Now see calculations. So 25 centimeter cube of K3FeCN6 is equal to A centimeter cube of glucose. Therefore, 10 into A mg of glucose is equal to, yeah, here it is, or you can say 10 A mg of glucose. काय नाही त्या ठिकाणी हे जे आहे ही क्वांटिटी किती? A सेंटीमीटर क्यूब ऑफ 1% ग्लुकोज आहे. त्याच्यामध्ये 10 A mg ऑफ ग्लुकोज त्यांनी त्या ठिकाणी सांगितलेलं आहे. बिफोर इन्व्हर्जन काय म्हणतोय? B सेंटीमीटर क्यूब ऑफ हनी सोल्युशन gives you 25, that is equivalent to the 25 centimeter cube or 25 ml of 1% K3FeCN6. Therefore, 10 mg of glucose, 10 mg of glucose will contain g gram of glucose. Let me check it out. 100 centimeter cube or 100 ml of honey solution will contain g gram of glucose. Now, what we are going to do? We are going to do the cross multiplication. This into this, okay, upon this, okay, that is equal to g gram of glucose. See, 10A into 100 upon B, that B comes to the denominator, and that mg of glucose is there. Similarly, we are going to do over here. C centimeter cube of honey solution will contain 25 ml of 1% or equal 25 ml of 1% K3FeCN6 solution, and that is equivalent to 10 mg of glucose. So okay, 100 centimeter cube of honey solution will contain, do the cross multiplication and take this C to the denominator, so that will give H gram of glucose, which is present in 100 centimeter cube of 100 ml of honey solution. Okay, so percentage of reducing sugar in honey, H into W, H upon W into 100, H upon W into 100. Okay, in this way, so percentage of reducing sugar in honey before the inversion is this one, and percentage of reducing sugar in the honey after after inversion is this one. Okay, so these are what the reducing sugar before inversion and after inversion we can calculate. Okay, after this topic or after this point we are going to continue with the tea. So I'm going to stop here for this lecture. Thank you.